Hello and welcome to yet another thrilling and chilling video about geometry. This is about triangle inequalities. And what we're trying to do today, we want to identify the angle and side relationships in a triangle. We want to identify angle and side relationships between two triangles. And then we want to solve some real-world problems involving relationships between angle measures and side lengths of one or two triangles. So the first thing we want to talk about is the angle measure and side length relationships in a triangle, okay? And so what we have is we have the triangle parts relationship theorem. And that says if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So let's put this into some context that we understand. We want to order, okay, so we're going to order angles and sides from smallest to largest. Okay, so what I want to do, and let's look at the sides first. Okay, and so what I notice here is that I'm going to order my sides from smallest to largest. And so my sides go from, and let me do this. Let me change up my colors a little bit. My smallest side is length AC. Okay, so my sides rank from segment AC, okay, which is 7, okay, and then to my next largest side, which is AB, okay, so that's AB, which is 13, okay, and then my longest side is 16, which is BC, okay, so BC is my largest side, which is 16, all right, and so the idea behind this, you know, I rank them AB, AC, AB, BC, but 7, 13, and 16, okay? Now I'm going to do the same thing, but with my angles, okay? And with my angles, if I were to do that and start that off, my angle measure that's the smallest is 30 degrees, which is angle B. So that's angle B, which is 30 degrees, okay? My next smallest angle is 62 degrees, which is angle C. So let me put that over here. So angle C, which is 62 degrees. And then my largest angle is angle A, okay, which is going to be 88 degrees. Whoops. So angle A, which is 88 degrees. Okay, and then there's angle C, which is 62 degrees. Okay, now what I want you to see here is that these angles and side lengths are related to each other, okay? And I color-coded them for a reason, so that we could distinguish between which one's the largest and which one's the smallest and the one that's in the middle. And the way that they're related is that you've got, you know, and I want you to see this, is that the side length that's the longest is across from the largest angle. Same thing with the medium side length, okay? That is directly across from the medium-sized angle. And the smallest side that we've got is directly across from the smallest angle. So, you know, and that's where this comes in, okay, is that the longer side is oh God, what does it say here? Here, let me zoom out. If one side of the triangle is longer than the other side, then the angle opposite the longer. Okay, just the idea is that the, you know, the shortest side length is across the triangle from the shortest angle. The longest side length is across from the longest angle, okay? So now let's take a look here, all right? So what I want to do is ordering the angles of a triangle. So we don't know what the angle measures are, okay? But we do know the side lengths of this triangle, WXY, okay? So what I want to do is we want to order the angles from largest to smallest. So let me do this, okay? I'm going to do largest to smallest. And when I'm doing this, I'm thinking about my side lengths first, okay? Let's do it for the sides, okay? Because once I do it for the sides, then I can do it for the angles. So I look for my largest side length, which is 11, okay? Let me do blue for that one, okay? So my largest side length is here, WY. So let me do WY, and that's 11, okay? And then let's look at my next smallest, which is going to be XY, which is 7, okay? So XY, which is 7, all right? The next thing I want to do is come over here and say, okay, what's my smallest side? My smallest side is WX, which is 5, okay? So WX, which is 5. All right, so then I want to take a look at my angle measures. So here's my angles. And so then, okay, so if WY was my largest side, I want to draw a line to the angle that's on the opposite side, that's across from that side. And that would be angle X, okay? The next one, okay, is XY, which is 7, and I need to find my angle that is across from that one, which is angle W. So angle W, all right? The last one was WX, which is 5, and let's find the angle that is across from WX, which is angle Y. Okay, so that's angle Y. And that's what we're looking for, okay? Now, do you have to write out all this stuff? No, not necessarily, but it will help, okay? What I'm trying to do is I'm trying to show you guys that, when you do this, it's pretty easy to figure this out once you, just look at the sides. Okay, now on this next one, it says the angle measure and side length relationship. So we want to use inequalities to order the angles from smallest to largest, given that the measure of angle 3, or that M, is greater than or equal to 3. Our variable here is M. So we don't really know what these side lengths are, but let's just do something here, and let's just let M equal 3, okay? If M is greater than or equal to 3, then this will, this is how it's going to work. So let's do this. Let's find out what XY is. First of all, let's let M equal 3, okay? So if I look at XY, okay, or I'm sorry, XZ, let me just rewrite this. Okay, XZ, all right? If we let M equal 3, then I'm going to plug in 3 for 1, and so I get 3 minus 1, which is going to give us 2, okay? So I'm going to give this a length of 2, all right? If I wanted to calculate the length of XY, okay, I'm going to plug in 3 for M, so I'm going to do 2 times 3 minus 1. So that's 6 minus 1, which gives us a length of 5. So this has a length of 5 here, okay? And then we want to do YZ, okay? And that's just going to give us 3 times 3, which is just going to give a, oh crap, this is 2 times 3 plus 2. Thinking wrong thing. Okay. 2 times 3 plus 2 is going to be 6 plus 2, which is going to give us 8. So sorry, this should be a value of 8. All right, not 5, but a value of 8. And then, okay, on the last one, 3 times 3, that's just going to give us a value of 9. Okay, so what I've done here, okay, is we can now order from smallest to largest. Now let's do this. So let me do smallest to largest. All right, and I'm going to color code these again. So my smallest side length, again, was XZ with 2. Okay, so XZ, okay, and that had a length of 2. And we're going to do this for the side lengths. All right, and then my second largest was XY with 8. So that's XY, and that's a length of 8. And then we have the largest with ZY, okay, or YZ, doesn't matter, do YZ, okay, and that had a length of 9, okay. So now what I want to do is I want to now do this for the angles, okay. So if I do it for the angles, then I'm going to go, okay, well, what's my smallest side length? That was XZ, so my smallest angle would be angle Y, okay. And then, okay, if I look at my next largest, which was XY, go to the opposite angle, which is angle Z, okay? And then the last one, okay, last but not least, we're going to go from the longest side to that opposite angle, and that's going to give us angle X. Okay, and that's how I'm doing it, okay? And that's just something where, you know, even though they don't give you actual values, they give you some restrictions, okay? As long as you plug in a value that's either 3 or larger than 3, then you can plug that in for m, figure out the side lengths, and then analyze how big those are, and then that tells you how big your angles are, okay? All right, last question on this page. Okay, Katie and Jacques are hiking on 2 different trails. They reach the end of their respective trails with a straight line distance between the 2 trails being 5 miles. So, okay, the angle between the line connecting Jacques and Katie, okay, and the line connecting Katie and the car is 50 degrees. The angle between the line connecting Jacques, Katie, and Katie and the line connecting Jacques to the car is 70. Okay, who has a longer distance to the hike back to the car? Okay, and so that brings us up a good question, okay? So because, and the way it goes, guys, even when you have the angles and the sides, okay, you can tell which sides are longer based on the angle measures, all right? So what I want to do is we want to figure out, well, which one of these sides, okay, and I'm going to call this X and Y, okay, so which side is longest, okay? Who has a longer hike back to the car, okay? So because, all right, so listen to this, because 50 degrees is less than 70 degrees, okay, then I know that Y is going to be less than X. So Katie, so this is going to be longer because 70 degrees is bigger, okay? This is going to be shorter, okay, because 50 degrees is small, all right? You kind of just have to think about it like that. So Katie, so in conclusion, our answer is that Katie has a longer hike back to the car. Okay? It appears as though Katie's a little bit more shape, or maybe the hike was just a little bit easier. But even though, guys, you know, and it kind of depends on the picture, but, you know, the pictures aren't always drawn to scale. You know, you can't really tell this just by looking at the picture. But if you have the angle measures, you know that, you know, they're going to follow the same thing. Okay? So that's the idea. Okay, let's take a quick look at the angle measure and side length relationships between 2 triangles. And what this says is the Hinge Theorem. If 2 sides of one triangle are congruent to 2 sides of another triangle, so I've got these 2 congruent segments and then these 2 congruent segments, then what we know is that depending on what this angle is determines which one is bigger than the other. So here I know this, that angle A is going to be less than angle D, all right? And so because of that, I can now say that I know that CB, that length of CB is going to be less than the length of FE, okay? And that's the idea. So it doesn't matter, you know, if these, you know, we're just you know, analyzing side lengths, you know, based off of angle measures. So it doesn't necessarily mean that because these 2 sides are congruent, that doesn't tell us anything about the third side. We have to know something about the angle measures in between, okay? And then there's a converse to that. Okay, and the converse is that, you know, if I know that you know, FE here is larger than CB, so the converse is that if FE, okay, is larger than CB, then what that tells me is that then angle D, okay, is going to be larger than angle A. Okay, so angle D is going to be larger than angle A. All right, and that's all we're doing on that. So I hope you enjoyed this video. I hope you makes a little bit of sense to you, and we'll see you on the flip side. Peace!